summer. So hot up here in the Northeast, let me tell you. And I hear over in Europe, it's even hotter. And you guys don't have air conditioning. So you may as well pop over here, watch the World Cup, get a little AC, maybe a couple beers, unless the Scottish drank them all. Anyway, we're going to air a classic episode this week. Episode 28, Fly Me to Mars on My Fart Rocket. That's right, the rocket science of farts. But that's just Julian's question. Mine has to do with the predictive powers of the 1993 classic film Demolition Man. That's not actually what it's about. But of course, I couldn't be me without bringing up a 1990s film that I really enjoyed, that I probably watched on Laserdisc, and then make a reference to how I used to work at a historic site. You know how it is. Long story short, you're going to get a great episode. It's going to be awesome. I think you're going to love it. Enjoy, and we'll see you with a new episode next week.
Hello and welcome to another episode of That's Absurd, Please Elaborate, the science and, gosh, I sure hope comedy podcast, where we take ridiculous, weird, silly, far out, strange questions from you listeners, or sometimes each other, or sometimes guests, and we do our very best to apply our years of science researching expertise skills that we've built up and actually find an answer. I am a host of the usual two, and I am Julian. We are going to get that someday. We're going to figure out.
We're going to get it. When's it? I'm just surprised to learn that we have skills. Like, I didn't know we had skills.
I guess skills, it's a strong word for what we have.
Yeah, we have a skill, and that is we can talk to each other.
We have ability, I guess?
No one said it was good. We didn't say good skills. Just skills that exist.
I have the ability to play a sport. Do I have the skill? Not necessarily. You know what I mean?
Yeah, I get you. I'm Trace, the other of the two, I think, that Julian mentioned earlier, typically found on this podcast. I also talk about science once in a while, and hopefully sometimes they're funny. Once in a while.
That is the goal. And we have another two cracking questions from listeners this week. Teeing us off for the first one, Trace, what is your question?
My question this week comes from Dartland, and his question is hypersleep ever a possibility?
Ooh, sci-fi.
Yeah, sci-fi. That's why I was like, as a big Trek nerd, I had to take this.
When they say hypersleep, do they mean like being really active in your sleep? Like you're hyperactive?
like a Berbiglia sleep.
Where you're about to jump out of a motel window or something.
Right, yeah. No, he does specify sci-fi. He says, another science fiction trope. In fact, the basis of the greatest cartoon of all time, Futurama.
Strong and correct opinion.
Yeah, exactly. Depends on the idea of having a living human being placed in some sort of quote-unquote cold storage and then revived later fully alive. Is this even possible? And if so, are we close? Why do you ask, Dartland? Like, are you looking to go to the year 3000? Like, I don't understand.
Honestly, the way things are going sometimes, I'm like, I could tap out for about 1,000 years. I don't care if I wake up and owls are the worst, like, parasite that we have infesting our cities. And, that's the only thing I remember from Futurama off the top of my head is the owl infestation problem. But, if I wake up to a radically different future, sometimes I'm like, I'll roll the dice. Let's find out.
Yeah, why not? In this case, Dartland didn't specify why he was asking, but there is some really neat science about cryonics, which a lot of people, when they talk about this, they use the term hypersleep or stasis or cryogenic freezing, cryo-freeze, all these different things. So Dartland is technically asking about, at least scientifically, what we know as cryonics. Sort of. There is a newer thing that we're going to get to in a minute. Yeah, I think you're going to love this, Julian.
Okay,
so cryonics, Julian and I have done videos on this over the years. It's not to be confused with cryogenics, which is really just making things cold. Anybody who is good at cryogenics, like making things really cold, could be any engineer or scientist. But cryonics is specifically making people cold or frozen. We learn about this typically when we're kids. We learn that the human body is mostly what, Julian?
Pizza.
Yes, in college. But what about generally?
Well, it's water. It's mostly water.
Yeah, it's mostly water, like 60-70% water. And water freezes at pretty easy to achieve temperatures. So we think, oh, well, if we're mostly water and we could freeze people,
right?
Could we just do that?
Yeah, just stick somebody in the freezer, chill out for a little bit.
And it turns out I was just going to keep going on that and just leave you there.
Acknowledge my pun.
So what happens when you put a water bottle in the freezer? Julian, have you ever put one in the freezer
I
for later?
sure have.
Yeah. Can you talk about that? What happens?
Yeah, so the sometimes, you'll break your dang water bottle because the ice, if it's a cheap little plastic one, right? Like the water freezes and the ice expands, and you can have a busted water bottle. Or if it's more robust, sometimes it might not freeze at all, right? Like if the water inside,
ooh, it's real strong.
Until you can like trigger that reaction. Also, it depends. You ever see those videos where they have like a really cold bottle of water and then they bang it on a table and it
instantly freezes?
So cool.
Yeah, those are super cool. Cool viral video science idea. The reason all this happens, the reason that the water bottle can pop if you put it into a freezer, or if you like put a gallon of water in your freezer and then the gallon kind of swells, right? And that's because, sort of like what we talked about in Matt Kroll's episode about ice being slippery, is ice forms little hexagons when it freezes. It makes little lattices. And that means that the space between the molecules is greater. So in a liquid, typically in a solid and a liquid and a gas, right? Gas has the most space, and then liquid and solid, it depends on the molecules. And in this case, water molecules and liquid can get closer together because they're like little Mickey Mouse heads. And when it freezes, it forms little rings. And so if you extrapolate that to human cells, do you think that it would be good if you were to freeze them?
I'm going to go with no.
That's safe.
I'm thinking of, do you remember when like Texas had that cold snap and all these houses that were built for like a very warm climate, so their pipes weren't like winterized? All these pipes were bursting in their houses and just flooding them.
Yeah.
I'm imagining something like that.
It's very bad. Yeah, it's very bad. If you took a little skin cell on your arm and you froze it, and you did it really quickly, cool. But mostly we're talking about a slow freezing, and that means it balloons and the water creates these spiky little hexagons, and those spiky little crystals don't like being inside soft membranes. And so what ends up actually happening, I do have a picture of this. Let me pull it up for you, Julian, is called the Swiss cheese effect.
Sounds like it'd be delicious.
Gross.
And then I thought, wait, but we're talking about like meat.
Yeah. We're talking about
like
meat.
People meat.
So
or meat in general.
There's a thing here. I'll put this on our Instagram. If you look at this picture, Julian, this is what happens when you freeze human tissue. On the left, it's the Swiss cheese effect. Does that look comfortable?
No. It looks like a lot of holes were punched in what was once a nice, more like continuous marbled slab of meat.
Yeah. So it would be very bad for us. And then if you look a little below that, you see the brain tissue and muscle tissue also doesn't turn out so great. It ends up with all these holes in it, and it looks terrible, and it would be painful and kill you, assuming that you could feel it while you were being frozen. So long story short, bad. Bad deal. Don't do the freezes.
This is why, like, if you put meat in the freezer, but it's best to put meat in the freezer by first cooling it close to freezing, right? And then popping it in the freezer after that, because it doesn't let those ice crystals slowly accumulate, right? You get smaller ice crystals, so you don't just like shred the meat as much. So when you pull it out and heat it again, it doesn't turn into like a goopy, gross mess.
Oh, you're the best.
Yeah.
Yes, exactly. So scientists use this snap freezing or in cell samples. So in this case, what you're talking about is I have this big slab of meat. I'm going to slowly cool it, and then I'm going to really cool it more quickly. And so you can do that in a lab with cell samples, embryos, and things. It's called snap freezing. The fastest way to cool something is with direct contact, thermal conduction. You're like pulling all the heat out of it really fast. And they can do this using dry ice or liquid nitrogen in a lab, and they can do it cellularly, not with like solid organs or full bodies. Anything that's like sub-gram sized specimens.
Right, because your issue with like a whole organ, if the fastest way is to transfer, that heat from the organ to the ice or whatever, if you're going to cool it down quickly by contact, you need contact, and if you've got a lump of meat, you're only touching the outside.
The edges. Exactly. So think of like an oven. You're cooking from the outside in, so you have to leave it in the oven for a long time. This is the exact same concept, but we're cooling instead.
We need an anti-microwave. We need something that cools from the inside out.
Yeah, if you snap froze 1 gram at a time, a human body, it would take a long time, like 24 hours or something, 25 hours.
Painful. Yeah.
Yeah, and you'd be dead for sure. And your cells would likely be pierced by the water that's inside of them, and it would be really awful. Not to say that cryonics isn't a thing. There are people who like get their heads frozen, and they're like, "Oh, someday I'm gonna be Richard Nixon," but it's not gonna happen.
More Futurama references.
Yeah,
Nixon's frozen head.
So let's just say cryonics not the deal.
Okay.
Except it's time to bring up the most obvious science fiction movie that I think really is it was prescient, you know? It just knew what was happening. One of the best science fiction examples of cryo-freezing in all of Hollywood.
Where's this going?
Demolition Man.
What?
The film Demolition, we were all thinking it, you know? Everyone out there in the audience, you were all thinking of Demolition
sci-fi.
Man.
When I think icons of sci-fi, I think
Sandra Bullock. It's made in 1993, set in 1996, and then also 2032.
Oh no, 2032.
32, yeah.
It's in 8 years.
It's coming up.
Oh no, we're gonna have to unfreeze him.
They're gonna have to make a sequel, I guess, because he's still kicking. So Craggly cop John Spartan, played by Sylvester Stallone, is pursuing a crazy criminal, Wesley Snipes, and things go awry. They're both convicted somehow, and this happens in just the first minute or two of the film, and they're sentenced to be cryogenically frozen for 70 years, but for some reason wake up 36 years into their sentence, and it turns out Wesley Snipes has been freed, and he's, wreaking havoc, and the only way to solve it is this old school cop, because the world is a completely different place. Anyway, we're not here to talk about the film so much as that cryo-freezing part of the film.
Is that really a punishment? Just as an aside? If somebody was like, you committed murder and you're basically going to take a little nap, you won't even notice you're gone. I'd be like, dope. Yeah. I know what I'm going to do when I'm out, which is commit murder again, Right.
Like if you committed a murder, went through the whole justice system, and then after you were done with that, they just put you to sleep and you woke up and it would have been in your mind 10 minutes later. They get around it by saying that during that time, they're subliminally rehabilitating you.
Okay.
In the movie, he takes up knitting, as I recall, in the film, because they rehabilitated him to take up knitting. But Wesley Snipes, they rehabilitated to be a hacker and a bunch of other things. Anyway, it's a great film. Highly recommend. In the movie, though, the cryo-freezing part, they put him in a tank, they cover him with a liquid, and then they drop this little blue MacGuffin thing that contains a huge amount of energy, clearly, because it cools him in 5 seconds of on-screen time. Like completely frozen, solid. And then they actually pan over during the long credits scene, because it was the 90s, and they show he's at 001 Kelvin.
Wow.
That's cold.
That's almost as cold as possible.
Yeah. So the cool thing about this is because we know that a human body is about a certain temperature and a human body is about a certain size, in case you're wondering, Sylvester Stallone is about 5'10", and at his largest was about 200 pounds.
There's no way.
But yeah, he's probably shorter than that. Doesn't matter. Anyway, we can do the math and figure out exactly how fast and how much energy it took to freeze Sylvester Stallone in about 5 seconds.
Okay.
Yeah. So it's heat transferred equals specific heat capacity times mass, and then temperature 1 minus temperature 2, or the delta.
Right.
So you've got 310.2 Kelvin. That's body temperature. And then we've got an isobaric heat capacity of flesh is about 3.5 joules per gram Kelvin difference.
Okay.
So 3.5 J over GK. And then we've got 3.5 joules of energy. That basically means that that's how much it's going to cost in energy to change 1 gram of human body tissue by a Kelvin.
One Kelvin
Temperature.
Okay, yeah.
So Stallone, again, is about 5'10" in Patriot lengths, or 178 centimeters, approximately 90 kilograms, which equals 20 bald eagles, or 400 double quarter pounders. So we're looking at about 90,000 grams.
Who said this show isn't accessible to an American audience? I don't... All these units make sense to me. For listeners, for context, we see analytics and we know like 52% of people listening are not in the United States. So guess what, baby? Metric wins. Yeah, if you want us to go back to miles per hour and cheeseburgers per bald eagle, you tell your friends about the show in the States. We will use whatever unit is currently winning.
We'll be constantly switching, which won't be confusing
on the audience.
to anyone. So anyway, this all works out to a negative 116 megajoules.
Okay, so it's a very, very, very endothermic reaction. It sucks a ton of heat out of this environment very quickly.
In 5 seconds. Yeah, it's 97,000 BTUs in change, or about 28 kilograms of TNT worth of energy.
Wow.
So like a good amount of energy. Not like a ridiculous amount, not like nuclear amounts, but like a good amount. 1 joule of power is needed for a 1 watt device for 1 second.
How many BTUs was it?
97,000.
What's a typical air conditioning like BTU rating? Do you know?
It's in the thousands. So like it would take, to cool a room could take an hour, and it's removing thousands of BTUs. Again, this is like 5 seconds, so it's pretty quick. If you think about it like a cell phone charger of 15 watts every second, this is going to take 116 million joules.
Yeah.
So, it's going to take a lot.
In a very short time. That's a lot of power, right? Power in physics is like energy over time, right?
Right, exactly. Yeah. We don't have the technology to fully freeze a 200 full-pound burger of American man meat in 5 seconds. But if we did, we could potentially solve this cryo-freezing issue. Because if you snap freeze a cell, it doesn't pop. For some reason, just like Julian, you mentioned with that viral water bottle, when you freeze water in a certain way, it doesn't form those hexagons, it doesn't pierce the cells, and it wouldn't destroy the human body. So if you could freeze it like this in Demolition Man, you would be able to potentially freeze people. Of course, now we still have to thaw them, which they didn't talk about at all, and you'd have to thaw them also very quickly. Also, if you jostle them when they're in prison, like if you slap do they just like explode because they do with the water bottle? I don't know. Since we're talking about one of my favorite Nostradamuses of Hollywood, I just wanted to tell you that in 1993, when this movie came out, they predicted that by the 2030s, we would see anti-smoking laws, computer terminals everywhere, Schwarzenegger would be a politician, hackers would be powerful in our society, self-driving cars would exist, video meetings, voice assistants, digital payments, commercialized nostalgia would be a deal, and of course, virtual sexy time. Not to mention internet-connected tablets and phones. All of this is in this film from 1993.
Whoa!
Right?
I'm going to confess, I've never seen Demolition Man. So I'm shocked.
You're coming over.
I know, we're going to have to do another movie night. I was going to say, they say Star Trek was so prescient, but no. Demolition
Man. I have a running list that I've kept since I was a kid of all the things that Demolition Man got right, and it's a lot. The only thing that he didn't get right is there's this thing in the movie called the 3 seashells, which is how you go to the bathroom, and that hasn't happened yet.
Yeah, we have eight more years.
Yeah, we still have 8 years. They also give you tickets as things happen. So like if you're driving and you speed, a ticket like happens, and I'm like, oh, we're not that far from that. And then of course, there's a quote in the film, the Taco Bell was the only restaurant to survive the franchise wars. But they don't explain what the franchise wars are. But I do think that could happen. Like, if you think about the meatless movement in restaurants, if you replaced all of Taco Bell with meatless meat and didn't tell anyone, would you even know?
Probably not.
Exactly. Right. Taco Bell could win the franchise war.
As someone married to a vegetarian, Taco Bell's surprisingly easy for vegetarians. So, like if we transfer to a meatless society, because of climate change, because of some dystopian, horrible future, right? Like I could see that also triggering the franchise wars and Taco Bell being kind of in a good position then.
In 1993, like all fast food was like burgers and meat and stuff. So of course Taco Bell could win the franchise wars. You swap out all that plant meat, Taco Bell wins. Out of universe, of course, like outside of the Demolition Man universe, the Demoverse, the Taco Bell just gave the filmmakers a bunch of money and they were the winners. So
they won the franchise bidding war for sponsorship rights.
Yeah. So this is the technology we have now. So to expand it past that, what do you think of when you think of something like stasis outside of freezing? Is there another thing that we could pull from in nature potentially that has to do with, laying around for long periods of time?
I feel like I'm being slow walked to hibernation.
Thank you.
Yeah.
That's correct. Hibernation is the exact thing I was trying to get.
Okay, good. We got there.
So hibernation is not sleep, but it's common amongst a lot of different animals. Common misconception is that it is sleep, but they're not. Like bears aren't in a cave sleeping for months. They're hibernating, which is a low level of activity, a lower heart rate, a lower body temperature, shallower breathing. It does look like sleep, but it's not the same thing. So during hibernation, also known as torpor, which is a different version for different animals, they don't eat, they don't drink, they rarely urinate, they don't poop, or they almost never do. And it looks a lot like sleep, like I said. But in the brain, during sleep, it's very active. There's lots of things happening, and they're going through these sleep cycles every 90 minutes.
Right.
In hibernation or torpor, it's way less activity.
I guess that makes sense because the brain is a big energy suck. Especially for humans with our big old brains. Takes up a
big old noggins.
A lot of the calories that you consume. So if you're trying to just keep everything at a low baseline to just wait out, the winter bad times or whatever, it makes sense to me that brain activity should drop too.
Right. And so this is what they thought. What if we could induce this in people, right?
Okay.
Because your heartbeat would drop to a few beats per minute. Your brain would have a lot less activity. You wouldn't be breaking down fat. You wouldn't process nutrients. Your cells don't die and they don't divide when you're in hibernation. It's just really interesting. OneSpace.com writer wrote that it's almost like hitting a pause button on life. And I have to tell you, the European Space Agency thinks that this is possible. And studies have shown that it could be done with humans.
Okay, yeah. I'm intrigued.
Yeah. Right. So Mars is 7 to 9 months away. Jupiter would be a year away. Space is real big.
Yeah.
Everybody.
And those are ideal launch conditions, right? If we...
Yeah, in the perfect world. Exactly. And there's problems with going to places like Mars. For example, food, waste, effects of microgravity, which you can mitigate with exercise but not solve. Even the astronauts on the ISS have those problems.
Yeah. You might get there and have to deal with Elon Musk.
Oh, God. That's where I was going. Yeah, I was going to also list psychological problems, which, hey...
Freeze me, please.
So human hibernation would mitigate all those issues. You're not going to have waste. You're not going to need food. You're not going to worry. In fact, because your cells aren't dividing and dying, microgravity is going to have a very minimal effect because you're not going to atrophy. Your body's not going to consume those cells. It doesn't need to. And so a study in 2023, literally last year, induced torpor in rats that don't do it. They fed them a lot of food, and then they had them fast. They put them into a dark, cool place and gave them a neurotransmitter that's common in animals with torpor. And as long as they were giving them the signaling drug, they went into torpor, and they just hung out.
I thought you were going to end it after they gave them a lot of food, and then the rats just crashed. I'm like, oh, well, I do this to myself all the time. Every Thanksgiving.
It's basically Thanksgiving plus a neurotransmitter. And for people outside of the United States, that just means we eat a lot and then sleep and pretend to watch a terrible, boring sport. So rats are obviously not equal to humans, but they were able to induce this torpor in rats. And it mitigates all of these problems that we might have going to space. And this would be, I think, the closest we could get to hypersleep or stasis is using this kind of a system.
That's ingenious, frankly.
Right?
That's really clever.
The neat thing about it, as I was reading about it, is that this neurotransmitter drug that they're using, if they stop giving it to them, they wake up from torpor.
That's great.
Which is very much like what you see in sci-fi, where they put a thing in their nose or they put a thing on their temple or whatever it is. They give you some bit, something. You lay down, and then there you are. You just hang out.
I like that because so many sci-fi horrors start when only one person is unfrozen and then there's a malfunction and everybody else is dead, the life support failed or something. But now it's just you just yank that little whatever thing
Stop
out of their
giving them
head.
the brain drug.
Yeah, and then they'll just wake up. So that's good. I like that.
I also think the cool thing is this fits with how we think about space travel in sci-fi of the time aspect of it, right? If you were, say, under anesthesia for this time, you're still aging. Your body is still working. Like your body is doing everything it does when you're awake. You're just not awake. And so that would mean over time, you go to Mars for a year, you lose a year if we just put you under anesthesia. Mm-hmm. However, if we were able to put you into torpor, your body's not dividing, which means it's not aging.
That's cool. There's
really
also
wild.
If somebody's under anesthesia, you're going to have to keep supplying them with nutrients the whole time, right? Like we mentioned, you're still burning that energy, your cells are still dividing and everything. So you've got to carry that as part of your payload and just basically waste it. But if you're in torpor and you have like a fat reserve as part of your astronaut training is just eating cake, I guess, which sign me up. But then like you don't have to bring the food for that part of the journey. That's also like a great weight saving technique.
Right? It's really incredible.
For the mission, not for the astronauts themselves.
Yeah, maybe both. Why not? You just have to eat a bunch first.
Oh, I can also see it catching on living in Hollywood as I do, as like a like weight loss technique. Like, hey, do you want to literally lose weight in your sleep? Like, knock yourself out for 6 months.
I mean, yeah, why not? That's actually something they think they can do for this. Not so much with torpor, but with, if you could figure out anesthesia, I guess. But like with torpor in medicine, they think they could use it to stop cancer cells dividing. Oh. So they could put you in torpor while the cancer doesn't progress while they treat you. They could put a whole organ into torpor before a transplant so it doesn't degrade. So I take it out of you, Julian, on the black market. I stick it into torpor, and now I can hold on to it until someone needs it, as opposed to having to like run right from you to somebody else. Like all of that could be kind of mitigated with this. It's not just space travel. It's really it's super interesting.
Question for you, and if your research didn't explain this, because I bet it's really technical, no worries. But how would you, if torpor is induced by like a neurotransmitter, how would you have an organ that isn't the brain? I don't know. Torpor.
This is something that they wrote about as an option, so maybe they still are working it out. But they know that, if maybe they can figure out what the brain is telling the organ, right? Like right now, you're just going right to the source, and maybe they need to go down to the organ level and be like, okay, well, the brain is sending this hormone or this transmitter to this organ to get it to do this. So we just bathe that organ in this synthetic version of that. But I'm totally, making that up. Like, I don't know the reality of it.
Yeah, I figured.
They wrote about it as like, these are the options that we could use this for other than space travel. Even though the ESA is looking at it, it could be used for other things. It would be like that actual pause button, and they could use it for all sorts of cool stuff.
That's so cool.
So kind of to wrap up here, Dartland, is, I think we could do hypersleep. And they're working on it now. Julian, do you have any idea, based on what I've told you and this like rat experiment, when you think that they could actually do this to people?
Okay, if we go by the Demolition Man timeline...
Amazing.
Since it's so accurate, apparently. Actually, yeah, sure, why not? If Demolition Man took place 3 years in the future of when the movie came out, let's say 3 years from now, I don't know.
Wow. I mean, you're not that far off. By Price is Right rules, you're still in the ballpark here. You're not close without going over. So they think they could do this by the 2030s. So in the next decade, we will be able to, they think, put people into what I'm going to call stasis, because torpor sounds really sad. But you could put them into stasis, hit that pause button, and let them go to another star, help us find cures for their diseases, and all sorts of other interesting things. So cool.
Yeah.
I just want to point out, this could also be a really interesting altered carbon, like get rich quick scheme. Like, think about it. You sell all your stuff, you invest all your money into an index fund, and then you pay somebody to put you in stasis for years.
Right.
If you invested $100,000 just into the S&P and, the world didn't end.
Right.
100 years from now, you'd have $130 million.
Yeah. I can see people who, want to make a lot of money and don't care that when they wake up, everybody they know and loved is dead doing that. Yeah. I get selling it on, like me getting added to a WhatsApp group, like promoting this.
Welcome to Stasis Crypto Bros.
To the moon,
24.
literally.
That's good. So yeah, you could do something like that if you don't care that everybody's dead. Okay, but since we're talking about Demolition Man, before I really do wrap, how come only 2 people are woken up from this prison ever? They never. The implication is that Sylvester Stallone's character woke up and is from the past, but he's an oddity, and everybody's like, you don't know all this stuff, and I'm like, Were there only 2 prisoners ever frozen?
Yeah.
No, we see all these other prisoners, like lots and lots of them. Did they all have none of them woken up yet? Like, is he the first person to ever wake up from this prison? That is a huge plot hole that does not make any sense.
Wait, you said Stallone was the cop?
He's the cop.
Why?
Wesley Snipes
Why
is the
was
criminal.
the cop also frozen?
Oh, don't ask.
Okay.
There were some people that died, and he got convicted of the same,
Okay. And now to clear his name, although apparently when he's unthawed, nobody gives a crap because nobody even knows who he is.
Yeah, no, see, he's unthawed to help catch the criminal, who is also unthawed.
Right.
And they need like old school tactics to get him because all their new school tactics are too gentle.
Right, and books don't exist
he needs to go
or
blow
anything.
stuff up. It's really it's a dumb movie.
We have no idea how anything in the past was done. We just that information is inaccessible to us.
We can't do any of those things.
We have to unfreeze a convicted murderer or something.
Well, go watch the movie.
90s action movie logic. Can't be beat. Well, Trace, that was actually fascinating. I think that was an ingenious plan from Issa. I'm kind of like excited to see if it works out. I kind of want to freeze myself until it's a thing.
Yes, you know,
paradoxically.
You'd have to just don't get slapped like a water bottle,
Right,
and then
or
you
dropped.
just explode or dropped. And thanks to Dartland for the question. It was really fun to look into. Let's take a quick break, and then Julian, you can tell me what you researched for this one. Welcome back to That's Absurd. Please elaborate. And I'm still thinking about Demolition Man. I don't know what you're thinking
I
about.
think I might have something that can still pull your focus from Demolition Man.
Okay.
My question comes from Ricky. And Ricky asks, how hard would I have to fart to lift off the ground?
Ricky. Ricky.
I just want to say, listen,
Ricky.
I try, whenever I read people's names, everybody's got like, sometimes we see names from like people from different cultures, and I don't want to comment or anything, or I never want to make fun of somebody's name. I do feel, however, that if this question were asked by anybody, it would be asked by a Ricky. Does that make sense?
It doesn't, but
This is a question. Like, I can't see somebody named like Isaac asking this, right?
It's got to be Ricky.
But my cousin Ricky would definitely ask this question.
Yo, Julian, I got this question. Julian, what's up? Hey, Ricky here.
Hey, Ricky, good to see you again.
Yo, how hard would I have to fart?
This is just...
You're right.
This is just a very Ricky question, and I can't explain it better than that.
I love it.
I don't know why, but...
Well, thank you, Ricky, for asking it. Yeah.
I do. Ricky goes on. He says, using farts as thrust, like a rocket, how much gas and how fast would it have to leave your body in order to lift yourself 1 inch off the ground? Assume I weighed 200 pounds.
Wow.
Again.
Did he just write you a story problem?
Actually, what I love, a little word problem.
A little word problem.
I love that Ricky was thoughtful enough to include several important variables that I otherwise was going to have to just assume or make up or look up. Ricky, kudos. Thank you for that, because it did make some of this easier, and this did involve math. So,
such a mathy episode. I'm into it.
It's quite mathy. So let's talk about, how rockets work, how jet engines work. And to understand that, we have to understand Newton's third law. Do you remember Newton's third law?
That if you eat 3 of them, then they're fruit and cake, not cookies.
If you eat 3, your mouth will be incredibly dry.
And they're delicious.
I don't know. Not a fan of Fig Newtons. Not a fan.
Oh, too bad.
Yeah. Big fan of Isaac Newton, though. And Isaac Newton's third law is for every action, there's an equal and opposite reaction, right?
I think you've just debunked your own. Would Isaac ask this? Because I feel like Isaac Newton would
think of that.
Be like,
Do you think Isaac was writing in his Principia Mathematica back when he was figuring out calculus, like doing the equation on like fart math
be like,
in his spare
passing
time?
gas. What would the thrust require?
Yeah, after eating the apples that fell from the tree and getting a little gassy from all the fruit sugars.
Yeah.
Yeah, he had that brainwave. So Newton's third law is for every action, there's an equal and opposite reaction. I think that's often misunderstood by people. And the way that I think kind of makes it more clear to think about is like when you push on something with a certain amount of force, that thing pushes back on you, right? If you were out in space far from any effects of gravity, right, and you were holding like a heavy like medicine ball or lead shot put ball or something, and you threw it, you would move in the opposite direction, and the forces would balance out, right?
Almost as if this location where you threw would be the middle.
Right.
And both you and the ball would move away from that middle.
In opposite directions, exactly. Right. So that's, we don't think of it here on Earth as much, it's not as apparent, but if the only forces acting on you were, the force that from the ball, then you didn't worry about gravity or friction or anything like that, it would be very apparent. And you could use it as a way of getting around. In fact, that is how jets and rockets do get around. They accelerate a mass of gas and they row it in one direction and it throws the rocket or jet or whatever in the other direction. And this is why jet engines, rocket engines, they're rated in pounds of thrust. Pounds, by the way, we think of pounds as weight, but pounds is really force. It's mass times acceleration. In non-freedom units, it's newtons, right? Newtons of force. So when you look at, jet engine ratings, like they have pounds of thrust ratings, right? Like 100,000 pounds of thrust or something like that. And that, is from the force of the gas being pushed in one direction, it pushes the jet or the rocket in the other direction. Is that all making sense so far?
It makes sense to me.
Okay, great. So Ricky's onto something here, is that you need to accelerate a mass in one direction and you can move in another direction, but it does mean that you have to accelerate, in our case, a gas really fast, right? Airplanes or rockets, they're massive.
Yeah.
The gas...
Literally.
Yes.
They have a lot of mass.
The gas that they're propelling is not very massive. So in order to make up for that, you need to go to the other part of that equation for force. You need to accelerate it a lot, right? And a lot of the time, it's like in a rocket, it's from combusting that gas, right? Because when you mix it with fuel and ignite it, it expands very quickly, and then you direct it out the back of the rocket. You'd be amazed, though, how much jet power, especially like a commercial jet, comes just from moving air. Not necessarily from mixing it and exploding it.
Yeah.
Modern jetliners use what are called high bypass engines, and basically there's a big fan stuck on the front of it, and 70 to 80% of the thrust comes from that fan just pushing air backwards, just a giant Dyson fan, basically.
Yeah.
And then the other 20% is from expanding exhaust gases. So with our farts, let's assume that we're not going to ignite them, because like a rocket, it would have to be ignited somewhere where you could then direct it, which would probably be in your rectum, right? Like if you're lighting it after it comes out, that doesn't get you any useful expansion, because it's just expanding equally in all directions. If we were to use expanding gases that we could direct, you'd want to do it inside you. And that is not advisable.
Deep inside of you.
The soft, squishy parts of your colon and rectum, they're not really made like a rocket nozzle to direct violently expanding gases in a certain direction. So let's assume that we're just going to be like a high bypass airplane engine and use just moving the gas alone just by accelerating it.
My sphincter is not going to do that.
Yeah. So... how fast, then, just would the fart gas itself have to exit?
Be moving.
A stage left.
Yeah. Stage down.
Stage down. Exactly. So here's where I had to do a little bit of research on farts. And I had to basically figure out, like, what farts are made of, because I need to know the mass of a typical fart.
Julian, the fart investigator.
I've filled up pages of a notebook, and it's all titled like fart math. If anybody finds it years from now, I'm going to look insane. Okay, I went around the internet, and everybody cites some different numbers and different fun facts. I did find a 1991 study that was examining basically how like diets, a normal diet versus a low fiber diet, how these different diets affected the amount of flatulence.
Like, because different foods, as you mentioned with the apples, cause different amounts of gas production.
Yes, exactly.
And of course, there's differences in biology and gut microflora.
Yes.
There's a lot of guessing.
Thank you for teeing this up, because you're exactly right. There's a lot of different things that can affect how much we fart and what our farts are composed of.
Oh.
So farts, if you didn't know, are the byproduct of when bacteria in your colon, your large intestine, are breaking down foods that our bodies couldn't break down. And these tend to be things that are like high in fiber, because fiber is like a chain of sugar molecules, but unlike starches, the bond is a different kind of bond. Starches are held together with an alpha bond, and fibers are held together with a beta bond. And that beta bond is more difficult to break, and we can't really do it. But the microbes in our gut can. So when this undigested food gets to them, they pig out, they produce a lot of gas as a byproduct, and then, we can turn around and use some of their waste products to break down for more energy and some sugars
I didn't know
that they
That's
free
neat.
up. Yeah. Thanks.
Gut microflora.
Gut microflora. Exactly. So if you eat foods that are higher in these fibers, or particularly raffinose is glucose, fructose, and lactose, and it's got a beta bond in it, and it's common in things like cabbage. And these microbes
that does it for me
go
for
to
sure.
town. Yeah. If you're trying to propel yourself with farts, definitely cabbage load.
Yeah, cabbage load.
Switch to an all cabbage diet, right?
It'd be so uncomfortable.
Yeah,
for everybody.
So, and like you mentioned, the composition of our farts can be different. Trace, true or false? When you fart, part of that fart is methane.
I mean, I assume it is. Yeah, I would say true.
In all likelihood, false.
What?
A minority of people have farts with methane in it. Like,
what?
Yeah, maybe about 30% of people.
So I might not be farting methane?
You probably don't
all
fart
of
methane.
the jokes I've told.
I know. I'm so sorry. You can call up all those people and apologize later.
I have to now. I have to go through my Rolodex.
By the
for
way,
young people, that's a set of cards attached to a tumbler.
Methane is odorless, is another common misconception.
Oh, yeah.
It's not responsible for the fart smell. A lot of people think that methane has a smell, and that's because like gas companies add an odorant to natural gas, which is just methane. So if you have a gas leak, you can smell it. If they didn't add that, you wouldn't be able to tell if you had a gas leak just from smell alone. So it would be really dangerous.
Yeah, I'm glad they add it. Yes.
But I think it's caused this conflation where people think, oh, natural gas, methane, natural gas smells, therefore when I fart, it's from the methane. It's not. The stinky rotten egg smell in farts, that's from hydrogen sulfate. So that's usually a byproduct of eating like meats, just sulfur and hydrogen combining, and then you get hydrogen sulfate. But not
sulfur.
methane.
What is with sulfur? Poor stinky sulfur. Always in all the things that smell.
Yeah.
Poor sulfur.
Yeah, but we need it for
It's such a lovely yellow
and
color.
Sulfide bridges are important in how your proteins fold. Anyway, so I found a study from 1991, and they had 10, quote, normal volunteers, although I'm sure they mean like there wasn't anything peculiar about them, but to volunteer for this study, I don't think you'd be normal, because these volunteers had a tube in their rectum for 24 hours, and they just collected all the farts from these people over the course of a day.
They had a rectum tube.
They had a tube coming out of their butt. Two of them to ensure that the tube was properly sealed and no gas was escaping. They even sat in a bathtub for an hour to make sure no bubbles were coming out.
They were like a butt Jetsons.
Yeah. So So they had like a bag on the other end of this tube, and they would swap out the bag like every half hour, every couple of hours, and they would collect and measure the volume of gas. And these people would make notes of like how often they farted, and so
Oh my God.
with all this, they were able to, kind of average out how much people farted, how many times a day, that sort of thing, and what the composition was.
Do you think there was somebody who they went through the experiment, they got their butt Jetson tube, they were all ready, and they were farting away, and then somebody dropped the bag filled with farts, and they're like, well, I'm sorry, all this data is ruined now.
We're going to have you
And
back
you have to spell this fart.
next week. Yeah, I totally believe that could happen.
That's awful.
Right. So the data from this study is as follows. During the day, so, while they were awake, up and about, the average amount that people would fart would be about eight toots.
8 toots.
8 toots a day. They would fart actually more in their sleep, but during the day, 8 times a day.
8 toots.
The median volume of each fart was 90 milliliters.
90. Okay.
Yeah.
90 milliliters.
Not very much, just a little
No,
boop.
like 18 teaspoons.
Thank you for converting that into freedom units.
I like to use the weirdest units.
Yeah.
They're the best.
Now, if a recipe calls for a teaspoon, you'll be like, 1/18 of a fart.
Yes, that's what I would have done, and now I have to.
Easy. That's easy for me to visualize.
Yeah.
Okay. And composition and volume, honestly, the graph, it's all over the place.
Oh.
So it varies a ton from person to person, but typically, do you want to guess what the most common gas was? About 50% of a fart. You want to know what it's made up of?
I mean, I'm going to guess nitrogen.
Oh, you're close. Nitrogen's a third.
Oh, okay.
Typically.
Just because there's a lot of nitrogen in the atmosphere,
Yes.
so I assume there's a lot of it from us too. But
Yes.
Other than that, I don't know. I mean, the carbon dioxide.
Carbon dioxide is third most, about 10% of the fart volume.
Okay, well, hit me. What
So
is it?
the most abundant gas in farts is hydrogen gas, just H2.
What?
Yeah, and that's a natural part of that bacterial process that's breaking down those starches.
No wonder it lights on fire in all the videos.
Yeah!
It's hydrogen.
Especially, right, if only a few people make methane. We know methane's flammable, right? But nitrogen, not under normal temperatures and pressures from like a cigarette lighter. CO2, no. So why does it light? Hydrogen.
Super flammable.
Very flammable. Hydrogen gas. That's right.
Wow.
So yeah, that's about 50% of the fart. And then, like you guessed, nitrogen, about a third, CO2, 10%. And then the rest, other various gases, right?
Yeah.
Okay.
Yeah. Trace elements.
Ha! Hey, that's the name of the production company of the show.
Thanks. Thanks. I shouted out myself.
Woohoo! Okay. So, with all this data, I can now figure out the typical mass of a fart.
Oh.
Yes.
Yeah, because you have 90 milliliters, and then you have the different elements that are involved.
Right.
So you should be able to...
I did have to make some assumptions about pressure and temperature. I assume when they actually measure the volume, it's cooled down to room temperature. And pressure, I don't know. I basically said 1 atmosphere. I figure maybe it's in equilibrium with the atmosphere.
If it were less than 1 atmosphere coming out of you, that'd be weird. And if it were more, it would fall. But it would immediately dissipate. I don't know. That's weird.
Anyway,
interesting.
These are assumptions I made just to be transparent about the math. Okay, so I took all that, and then I also figured out, the molar mass of a fart based on these gas compositions, right?
Wow. Yeah.
I know, I had to do a lot of math for this one, Ricky.
That's a lot of
Ricky, I hope you appreciate it. Okay.
Ricky appreciates
So
it.
CO2 has a molar mass of 44 grams per mole, nitrogen 28 grams per mole, hydrogen has a molar mass of just 2 grams per mole. And the fact that it's very light as a gas and that it's the biggest part of our farts, that's bad news for our fart rocket.
Our fart rocket?
Right. It would
Our
be
frocket?
It would be nice if we had more heavy gases, but no, we don't.
Hydrogen.
Right?
That's unfortunate.
But if you add up these molar masses in the appropriate ratio, you get a molar mass of a fart of about 15.76 grams per mole. I then used the ideal gas law to try and figure out how many grams per, fart, basically.
Yeah. Now that you know basically now that you know the mass of all of the different things in the fart, now you can figure out based on the volume of the fart roughly
Pressure and temperature, yeah.
And pressure, temperature, yeah, exactly. Okay, wow, this is a lot of math.
It is. So I got a typical fart of 90 milliliters should have a mass of about 0.0588 grams. Not a lot.
Okay, that's not a lot of mass.
Not a lot.
So if you're moving somebody who's, what was Ricky?
He's 200 pounds.
Okay.
Which, again...
It's like 91 kilograms-ish.
It's easy to just transfer that to newtons, right? Because, like I said, pounds and newtons are different names, but describing the same thing. So Ricky's about 890 newtons, okay? So we're going to have to overcome that force of gravity acting on Ricky. So we're going to have to provide 890 newtons of force.
Yeah.
And then we're going to have to provide additional force that's going to lift him 1 inch into the air.
Oh, God.
Yeah. So I did more math. I wrote in my notes after finding out that we only fart basically 0.058 grams. I wrote, yikes, Ricky's going to have to fart so hard. Okay, so I have my notebook of fart math over here.
Okay, we've got our fart math notebook.
He wants to go up 1 inch or 2.54 centimeters. I'm going to assume this fart lasts 1 second. And that's just to simplify some math, right? But I think that's like a reasonable, it's kind of a drawn out fart. Yeah.
Just like a quicken. Yeah.
Hold on, Kyle could do this very precisely. Kyle, can you insert a fart that lasts exactly 1 second?
Great.
Thank you, Kyle.
That's awful.
So now we all have a sense
we know exactly
of how long one
Man, this is a classy show.
is going to take. Okay. So if he's going to travel a distance of 1 inch, that means he's going to have to accelerate 0.05 meters per second squared upward.
Okay, yeah. Oh my God.
Now, Ricky's mass is 90.9 kilograms, right? So to accelerate that on its own up to the height that we need, we would have to provide 4.54 newtons of force, but that we then have to add to the 890 newtons of force that's pulling down on Ricky for a total upward force of 894.5 newtons.
Oh, God.
Okay, now, force is mass times acceleration, right? Newton's third law, equal and opposite, right? So I need to get that much force using just the mass of the fart that I previously deduced.
0.05 and change
grams. Not kilograms.
That's so
grams. Okay.
Oh, God. Sorry, I had to cover my face. That was awful.
Rearrange F equals ma to give me just acceleration. I divide 894.5 newtons by 5.9 times 10 to the negative 5 kilograms, and I get an acceleration of... It's such a ridiculous number. It is so good. 15,161,016.9 meters per second squared.
Oh my God.
Now I'm going to be really generous and assume...
Please put that in perspective. Oh my God.
Okay, I'll put that in perspective. So you would basically have to have an exit velocity, right? Because you're accelerating this gas for 1 second. The exit velocity of this gas would have to be 15 million meters per second.
This is a superpower.
To put that in perspective, the exit velocity of the gas of the Saturn V first stage, the rocket that sent astronauts to the moon, was 2,400 meters per second. According to ye old Wikipedia, basically like the top speed that you can get from a rocket fuel, like the exit velocity of the gas, is about 4,500 meters per second.
Wow.
So you're going thousands of times faster with your exit velocity just with your rectum, right? Like a typical fart goes about 10.9 kilometers per hour.
Yeah.
Its exit speed. This, if I convert meters per second to kilometers per hour, it's 54 million kilometers per hour. So you'd have to fart literally 5 million times harder, Ricky, to lift yourself off the ground 1 inch. It's just mind-boggling. It's just not doable. I don't care if you like save up all your farts all day so you have like more mass,
but still,
and so you don't have to accelerate it to as high a velocity. I don't care how much cabbage you eat. It's never going to happen.
Yeah.
It's even if you had like an iron rectum, which my nickname in high school, but like, and it was like properly a rocket nozzle shape to like accelerate like the expanding gas on its way out. It's totally undoable with this tiny amount of mass provided by human farts. But I love the question anyway.
Yeah. You'd like shred your pants. This would be serious stuff.
Yeah.
You'd
blow the pants right off. You would easily blow your pants off.
Oh my gosh. Wow. Yeah, you would be in dire straits.
Yeah.
For sure.
Yeah.
And it would happen so fast you wouldn't even really know what happened. Julian.
Can you imagine somebody just lifting off the ground for a second?
And their pants are gone. The ground is on fire. Everyone's deaf. Ricky!
Ricky, I told you not to eat that much cabbage!
What did you do? You know what? Now I get why you think a guy named Ricky would do this, because...
Come on.
Definitely.
Come on.
Yeah. Thanks, Ricky. That was amazing.
Thank you, Ricky.
Wow. Oh my gosh. I need to like come down from that.
Gosh,
that was
incredible.
Amazing.
Incredible. Man. Okay. Well, with that, thanks for listening to this episode of That's Absurd. Please elaborate. This show is created, written, and produced by me, Julian Huguet.
And me, Trace Dominguez.
And produced and edited by the wonderful, and as far as we know, not flatulent, Kyle Sisk. Have you ever heard it? Because I haven't.
I've never heard it.
Haven't heard it.
Special thanks to those listeners who submitted questions featured in this episode. Ricky, of course. I think we'll all remember Ricky forever. And Dartland. If you'd like to submit a question, look for the form down in the show notes. You can go to our website, that'sabsurdshow.com/ask to submit a question, or you can just email us or send it to us directly using social media. We will put that question into our rotation, and we could not do this show without your questions. So thank you all of you for sending them in. We are getting them on Spotify. We're getting them on emails. We're getting them everywhere. Really, really appreciate it. We're so excited to tackle all of these.
And finally, a special thanks to those listening on Nebula. Nebula listeners get access to ad-free versions of episodes and can even support us and other excellent independent creators. To join Nebula, visit go.nebula.tv/that'sabsurdshow.
And remember, one small toot for man, 1 inch lift for Ricky.
Oh, it would have been easier on the moon. I could have figured that out.